In this video, I'm still working through the ESA Study Guide Level 2 Chemistry textbook, and I'm going to be reading or going to work through some problems, starting with activity 11B, which is on page 141. All right, and this video is actually dedicated to or will have some problems that actually involve calculating energy or enthalpy changes. Alright, so let's read the first question. The first question says, when 6 grams of magnesium burns in excess oxygen, magnesium oxide forms and 150 kilojoules of energy is released. So 6 grams of magnesium burns in excess oxygen. Magnesium oxide forms, energy is released. It's an exothermic reaction. So the question is then, find the heat released if you had 2 moles of magnesium burning. This is the amount of energy that is released. This is the amount of energy that's released. That's 150 kilojoules when you have 6 grams. But they want you to find out how much heat will be released if you have 2 moles of magnesium. Alright, so I think it would be good to start with an equation, because they have not actually provided you with one. So you have magnesium, which is a solid. You've done this probably in year 11. Yes, I think it was probably one of the combination reaction that you did in year 11. Reacts with oxygen, which is a gas. It's a diatomic molecule, so you got O2. And that forms solid magnesium oxide, MgO. Okay, to balance this equation, I put a 2 in front here and a 2 in front here. Okay, so we don't know the delta H for this reaction. We don't know, we're not given this. Whereas what we are given is that when you have 6 grams of magnesium, if you had used 6 grams of magnesium, the amount of energy that would be released is 150 kilojoules of energy. So now they want you to find out how much energy will be released if you have 2 moles, which is what we have here. So how do we find this? Now you can't have a relationship between, you can't use this straight away because one of your values is in grams and the other is in mole. So you need to take the 6 grams and convert it to mole. Alright, so your first step one would be to convert gram to mole. Alright, how do you do that? You remember your equations. N, which is the number of mole, is mass divided by molar mass of the substance. Okay, little m, it represents mass, and uppercase M represents molar mass. So N is equal to little m over big M. So what is little m in this case? It is 6 grams. And uppercase M, which is given to us in the question, molar mass, is 24.3 gram per mole. So that's 24.3 gram per mole. And it's always given to you in the exam, right? So the gram and gram cancels out. I get my calculator and enter these numbers. Okay, so we need to take 6 grams and divide it by 24.3. Because I've got such a big number and I'm not actually doing this for accuracy, I'm going to take the first 3 significant numbers. So it's going to be 0.24 and that will become 7. Right? So my answer here will be, that is 0.247 and the unit is mole. So don't forget to write the unit and also say what this is. This is the N for magnesium. Alright, N of magnesium is 0.247 and it's in mole. So what is step 2? So what we've done now is we've taken the 6 grams and converted that to mole. So in step 2, we now come back to that first equation that we had, because in the place of 6 grams, I now know how many moles that is, and that is 0.247 mole. So that means 0.247 mole gives me releases. So when it's released, it's negative 150 kilojoules of energy. How much energy will be released when you have 2 mole? And that's the question. Will give us how much, we don't know. That's X. So what I'm going to do now is I'm going to cross multiply. Okay. So a cross multiplication, 0.247 mole times this X, and the 2 moles times the 150 kilojoule per mole. Alright, now I'm going to just solve for this X. That means I take this value and because that's in the numerator, I bring it down to the denominator when it goes on the other side of the equals to sign. Divided by 0.247 mole. Alright. So let's see what that works out to on the calculator. So step 2 is 2 mole multiplied by negative 150, and I divide that by 0.247. So my answer is that X is given to us as 1214.5. I've actually got more than 3 significant figures now, so I could just keep that as X is equal to 1215, and the unit for this one is the mole on top and the mole down get cancelled, and so the unit is kilojoule. That is the amount of energy. So I can't leave this with an X. I need to state what that is. 2 moles of magnesium will release 1215 kilojoules of energy. Now we can use this word release, or we can, and because we've got a negative sign there, there's a negative that stays throughout, we could use that. But you don't have to put the negative sign, because I'm using the word release. It is automatically taken that this is an exothermic reaction. Alright, so that's the answer to that question. 2 moles of magnesium will release 1215 kilojoules of energy. Okay, let's go to the next one. The next question reads like this. The next question says, the equation for the burning of carbon is carbon solid burning with oxygen, which is a gas, to form carbon dioxide, and the delta H for that reaction is negative 400 kilojoule per mole. That means it's an exothermic reaction. So they've given you an equation for the burning of carbon. This is what happens when you burn wood, paper, anything. Now, they want you to calculate the delta H when 6 grams of carbon is burnt. Alright, so what we'll do now is we'll go and I'll just copy this equation into my book, and then we'll do the calculation. Okay, so the equation for us is this. Carbon, which is a solid, combines with oxygen or burns in oxygen to form carbon dioxide, and a lot of heat is given out, and the heat is delta H, which is negative 400 kilojoule per mole. So it's an exothermic reaction with heat being given out of the given out by the system to the surroundings. So I've taught you how to read this equation. Now this equation reads like this: 1 mole of carbon reacts with 1 mole of oxygen to form 1 mole of carbon dioxide. Alright, but the question says, okay, right, that's all right. We know that 1 mole of carbon burning gives you 400 kilojoules of energy. How much energy will be released when you have 6 grams? Okay, so you know that you have to work through 2 steps, because you cannot work with grams. You got to convert that to mole, because your energy is always expressed as kilojoule per mole, never as grams. So the first step I take is I convert that gram into the mole, which is the unit that I can use for energy calculation. The equation we use is N is equal to, which is N represents number of moles, little m is the mass, and molar mass is uppercase M. In the question, the little m, or the mass given to us, is 6 grams, and the molar mass, if you look at the textbook, they gave us the molar mass of carbon and the molar mass of oxygen. That's probably just to confuse you, because that's the one I'm looking for. The question is about carbon burning. So I pick up the molar mass of carbon, and it is 12 grams per mole. Alright, so just be careful when you're selecting data that's given to you in the question. They may just put in some things there to confuse you. So we've got the number of moles. I'm just getting my calculator. So I've got 6 grams divided by 12 gram per mole, which gives me 0.5. Okay, so that's going to be 0.5. The gram and gram get cancelled. This mole comes up to the numerator, so it's just going to be mole without the power gets changed to a positive. So it's just 0.5 mole. Always state what this N is. This is N of carbon. Alright. So what I've done is I've taken the 6 grams that they were talking about in the question and converted it to mole. And then I can form a relationship with the equation that I have on top. Because this equation says, so I'll zoom out a bit so you can see the equation on top. That equation says that if you have 1 mole of carbon, the amount of heat released is 400 kilojoules of energy. So now I don't have 1 mole, I only have 0.5 mole of carbon. How much energy will it release? Now this is a pretty simple calculation. If 1 mole gives you 400, 0.5, which is half of that, will give you half the amount of energy. That would be 200 kilojoule per mole. So that's pretty much something you don't have to go through the normal steps. But if you want to stick to the steps, you can do that. We're going to cross multiply and then solve for x. Okay, so that's going to be 1 mole of carbon multiplied by this x is equal to negative 400 kilojoule times 0.5 mole of carbon. Therefore, x is going to be equal to negative 400 kilojoule times the 0.5 mole divided by, that's in the numerator there. When it comes to the right side, it goes to the denominator. Mole and mole cancel out. Negative 400, so 0.5 times the 400 will give me 200. Okay, so with the negative side, that's 200 kilojoules. So don't forget to include the unit, and also always finish the question by saying what this 200 is. Link it back to the question that they asked you. So 6 grams of carbon will release 200 kilojoules of energy. So is that the question? Is that what they wanted? Question says calculate the delta H when 6 grams of carbon is burned. So yeah, so we've got 6 grams of carbon will release negative 200 kilojoules of energy. Okay, so that's the second question. Now let's look at the third question in this book. The third question reads like this. The reaction between hydrochloric acid and sodium hydroxide is represented by an equation. H plus ions reacts with OH minus ions to form water, liquid water. We know that that is neutralization. The delta H for that reaction is negative 57.4 kilojoule per mole. So the two questions that follow that. The first one says, is this reaction exothermic or endothermic? Now, just by looking at the sign that they've given for delta H, because delta H is negative, I know this is an exothermic reaction. And I explain my answer in that way, saying delta H is negative and hence this is an exothermic reaction. Now, the next part of the question is interesting. It says 0.5 moles of hydrochloric acid reacts with 0.5 mole of sodium hydroxide. Calculate the enthalpy change of the reaction. So what they're doing is, although they're talking about hydrochloric acid and sodium hydroxide, they don't actually include that in the equation. The hydrochloric acid donates H plus ions, so that's all they've got there. The sodium hydroxide, the Na plus is a spectator, so they leave that out and they only deal with the OH minus. Okay, so these two get together and form liquid water. But the way you read the equation I've taught you is that 1 mole of H plus ions reacts with 1 mole of OH minus ions to form 1 mole of water. But their question is, no, we don't want about 1 mole. We want to know what happens when you have only half a mole. 0.5 mole of hydrochloric acid, which would be a H plus ion, reacting with 0.5 mole of sodium hydroxide, which would be a OH minus ion. Again, they'll form liquid water, but they want to know what the delta H will be this time. Okay, so let's see how we will solve that problem. So that's question 3. And it's part B to that question. Okay, so from the equation we know that 1 mole of H plus reacts with 1 mole of OH minus ions and releases 57.4, which releases, so that's a negative sign, 57.4 kilojoule per mole. We don't have 1 mole, we have half of that, so it's 0.5 mole of H plus 0.5 mole of OH minus will give me half of this. So pick up your calculator. 57.4 divided by 2 will give me 28.7. So my answer here will be negative 28.7 kilojoule per mole. So I don't need to really do any steps for this. It's pretty straightforward, this particular question. Okay, so have we answered the question? Is going back and reading. 0.5 moles of hydrochloric acid reacts with 0.5 mole of sodium hydroxide. Calculate the enthalpy of the reaction. We have calculated it to be negative. So I might just finish the question with that. With words from the question itself. The enthalpy of the reaction when 0.5 moles of HCl and sodium hydroxide react is, what's the number? Negative 28.7 kilojoule per mole. Alright, so we've answered that. We can move on to the next question, which is question 4. Alright, question 4 is it's longer. It's got 3 parts to it. So let's read it and see what we need to do. Now, question 4 says, for the reaction nitrogen, which is N2, reacting with hydrogen, 3 moles of that hydrogen, in fact, to form 2 moles of NH3 gas, which is ammonia. So 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. The delta H for that reaction is negative. That means this is an exothermic reaction. So there's 3 questions they have here. 1, they want you to find out how much energy is released if you had not 1 mole, but if you add actually 2 moles. How much would that be? That would be double, right? So you just multiply that by 2. Then find the energy released when you have 0.5 moles of ammonia formed. If you have 2 moles of ammonia formed, you have 92 kilojoules of energy released. But you don't have 2 moles. They want to know if you have just a quarter of that. What if you had only 0.5? You'd have quarter of energy as well. So we just need to divide that by 4. And then the last question is, how much nitrogen must react to produce 1,840 kilojoules of energy? So they're saying, I know that 1 mole of nitrogen will give me 92 kilojoules of energy. But you go and find out how many moles do we need if I want not just 92, I want much more energy to be released. I want 1,840 kilojoules of energy to be released. So let's work through these 3. Alright, the first one is pretty straightforward. So question 4. I'm just going to copy the equation so that I have it in my working here. We have nitrogen